Good day, everyone. Today, I will be discussing to you the types of reliability. So there are 5 types of reliability, but I'm going to discuss just 3 types. The first type is parallel forms reliability, also called as equivalent forms reliability. This type of reliability consistently measures the same thing, even in different versions. For example, you made 2 math quizzes with different questions but covering the same topics, and your students' scores about the same on both. Then your quizzes have strong parallel forms reliability. At the top side, you will see the formula for parallel forms. The meaning of the letter R is reliability coefficient, or how strong the relationship is. The X represent the scores on the first test, while the letter Y represent the scores on the second test. And N is the number of students or people who took both tests. Let's say 5 students took 2 math quizzes that are supposed to be parallel. So we want to know how similar the 2 tests are. Example, if the same students score similarly on test A and test B. To do that, we compute the correlation between the 2 sets of scores. A correlation near 1 means the 2 tests give very similar results. So we have to find the data. As you can see, there are test A and test B scores. In test A, there are 90, 80, 85, 70, and 95 scores. And in test B, there are 92, 78, 88, 72, and 96 scores. So we now have the 2 lists of numbers for the same people. We then add up simple totals. We have to compute totals because the correlation formula needs the sum of A scores, the sum of B scores, the sum of each score squared, and the sum of the product of each pair. So from the data, the summation of X is 420, summation of Y is 426, summation of X and Y is 36,160, the summation of X squared is 35,650, and lastly, the summation of Y squared is 36,692. We then build the top part, or the numerator. As you can see in the image, in the third image, as you can see, the numerator became 5 multiplied by the summation of X and Y minus the summation of X and the summation of Y. And for the denominator, it has 2 parts. The first part is 5 times 35,650 minus 420 squared. Second part is 5 times 36,692 minus 426 squared. So we have 5 times 36,160 minus 420 times 426 is equals to 1,880. So that's our numerator. And then for the denominator, we'll be multiplying those spreads and take the square root to get the combined scaling factor. After we do that, we'll have the answer, and it is 1 and 9,158,288. So after that, we'll now divide the numerator by the denominator. And the answer would be 0.98. So in plain words, it means that the two tests are very similar because 0.98 is very close to 1. So these two forms of the test are excellent parallel forms reliability. The next type is the internal consistency reliability. It checks how consistent the items in a single test are with each other, meaning all questions in a test should measure the same concept or skills. Example, you're going to give a test to your students about basic algebra, then the items should all be about it and it should not include random questions about geometry or the likes. For it would lose internal consistency because not all items would test the same topic. The last one is the inter-rater reliability. This type checks how consistent the scores are when different people, like raters or judges, evaluate the same performance or work.